All right, folks, it's Monday again. We got another week of practice. This week we're going to be working on some of the different properties of exponents. So we know how to add and subtract numbers like 5 plus 6, but how do you multiply or add numbers together when you have exponents? So let's just get right to it, and I think examples will speak louder than words. So the first one is, let's just say we have 2 to the third times 2 to the third. 2 to the third times 2 to the third. Okay, so essentially what this means is this one here, another way to write that is 2 times 2 times 2. 2 to the third means 2 times 2 times 2. This is multiplied by, so we can put another multiplication symbol here. Same thing, 2 times 2 times 2. So essentially we have 2 times 2 times 2 times 2 times 2 times 2. So we have 1, 2, 3, 4, 5, 6, which is the same thing as 2 to the 6th. So when you have 2 to the third times 2 to the third, another way you can write that is 2 to the 3 plus 3. 2 to the 3 plus 3, which is 2 to the 6th. Okay, let's look at another one here. The next one is power of a power. Power of a power. So let's just say we have 2 to the third squared. So 2 to the third, all of that squared. Essentially, what that means is we have 2 to the third times 2 to the third. Right? If we had 5 in the middle, instead of 2 to the third, if this was a 5, it would be 5 times 5, 5 squared. So because we have a 2 to the third in the middle, this is 2 to the third times 2 to the third. Okay. So this now brings us back to the last problem we did. 2 to the third times 2 to the third is the same as 2 to the 3 plus 3, or 2 to the 6th, or 2 to the 6th. Okay? So that's when you have exponents outside. So another way to say this is 2 to the 3 times 2. 2 to the 3 times 2. I'll do one more example because that was very similar to the last one in the numbers. So let's just say we had 3 squared to the 4th power. 3 squared to the 4th power. That essentially means 3 squared times 3 squared times 3 squared times 3 squared. That to the 4th means multiplied 4 times. Okay? So if we expand this out, each one of these is 3 times 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 3. That's 1, 2, 3, 4, 5, 6, 7, 8 for 3 to the 8th. Okay, so that's how we got it. A more simple rule, if you just take 3 squared to the 4th, you can say that's 3 to the 2 times 4. 3 to the 2 times 4 is 3 to the 8th, right? This is the long way. This is when we use the exponent rule. Okay. The next one is if we have division or fractions. Let's say we have 5 to the 4th divided by 5 squared. 5 to the 4th divided by 5 squared. So if we wanted to rewrite this, we could say 5 times 5 times 5 times 5 divided by 5 times 5. Okay? And we know from our rules of cancellation that if we wanted, we could cancel 2 of those. And we would be left with just 5 times 5 on the top. Nothing on the bottom. So the denominator would end up being 1. So we would end up with 5 squared. 5 squared. Okay, another way to think of this here, right? Another way to think of this is if we had 5 to the 4th over 5 squared equals 5 to the 4 minus 2. You take the numerator and subtract the denominator. So that's 5 to the 4 minus 2, which is 5 to the 2nd, or 5 squared. You see how that works because 2 on the bottom will cancel out or take away from 2 on the top. So the only thing you're left with is 2 on the top there. So that's for when you have a fraction with exponents here. Let's look at another one, a little different. What if you had 6 to the 3rd over 6 to the 7th? Okay? So we know that we can say 6 to the 3 minus 7. So another way to say that is 6 to the negative 4. So you can pause and think for a second, what is another way to think about 6 to the negative 4 if we know how we got this problem? You can pause the video if you want to think about that. If not, here's the solution here. You can say, rewriting this, 6 times 6 times 6 on the top, divided by 6 times 6 times 6 times 6 times 6 times 6 times 6. That's 7 6's on the bottom. Cancel, cancel, cancel. We're left with 1 as a numerator, and we have 4 on the bottom. So another way to write this, 6 to the negative 4th, is 1 over 6 to the 4th. Either one works. Either one works. Okay, and then lastly, is if we have a fraction inside of parentheses with an exponent on the outside. Let's say 3/4 squared. 3/4 squared. So another way to think about this is simply rewriting it. Always it's good to just rewrite it. That's 3 over 4 times 3 over 4. You essentially take whatever's inside and multiply it by itself twice, because that's what squared is representing here. So when multiplying fractions, you just multiply across the top and you multiply across the bottom. So in this case, you would end up with 9/16. 9/16. Another way to think of that, this is more of a solution. Another way to think of that is simply 3 squared, right? 3 times 3 is 9, divided by 4 squared. So 3 over 4 squared is the same as 3 squared over 4 squared. Here's more of a numerical solution, and here's a simplified representation. Reach out if you have any questions.